Happy day and welcome everyone. Today we are talking indicators, and this is going to be pretty quick, but I did want to run through a little bit of a reading with you on indicators and how they work, and then I also wanted to show you some indicators. Okay, so I'm actually using some household stuff here to show you. I have some distilled vinegar, so just regular white vinegar, and then I have some just pure baking soda, and so these two I have put either in beakers, or I also have this depression, this spot depression plate that's down here as well, okay? And so between these two, I'll kind of give you an idea of how this works, okay? So the first thing I wanted to show you is actually something very simple. It's called litmus paper, and so this happens to be blue litmus paper. And so what I can do is I've got some, this is my vinegar that I have in my slots 1 and 2, so I'm just going to dip this in the vinegar. And what happens with litmus paper is it turns pink when it's in acid, okay? So that's turning a pink color, right? And then I'm going to take the same thing, and then in this plate here, I've got some base. And so this is my baking soda, and baking soda is basic, and so I can see that in a base it's blue, and red litmus paper does the same exact thing. So it's like pink in acids, and it's blue in bases. Okay, so easy to remember, be blue. Okay. Now, the other thing that I have is this InstaCheck right here. And so I get this little paper out of this, and then all I'm going to do is match up with my color wheel. So I'm going to do the same thing. I'm going to dip this in the acid. And so this is my vinegar, and my vinegar is coming out, and you just match the color, and it kind of looks like yellow, like a pH of 5, something like that. And so you can see that this has, this little color wheel has some different colors on it, and so I can just match it right on there. And then I'm going to dip it in my baking soda here. And again, baking soda should be basic. And so what I'm seeing here, it's dripping a little bit. So what I'm seeing here is, oh, not too bad. It looks like it is getting a little bit darker, but this does more look like a pH of maybe a 7 or an 8. So, so nothing too intense, but definitely more basic. Okay, now some of the other things that I have to check with is I can use bromothymol blue. And bromothymol blue is blue in bases, and then it's usually like pink in acid. Okay, so let's see what happens when I put it in the acid. So this one right here, this space right here is an acid, and so let's drop it in there. And it's looking to me, it changes colors and it turns yellow. Okay, so that's turning more of a yellow color. And then let's do the same thing in the base. And in the base, it's actually blue. Okay, so we can see that. Phenolphthalein. So I know we've used phenolphthalein a couple of times, but just so that you remember how phenolphthalein works. So phenolphthalein in acid, so I'm going to drop it in my vinegar, and it's not doing anything. It just stays clear. It just gets a little bit cloudy because I added a few drops. But in my base, it's actually turning a pinkish color. Okay, so I don't know if you can see this, but it definitely turned to a pink color. Okay, so for phenolphthalein, if it's clear, then it's an acid, and if it's pink, and usually it gets kind of a bright pink, but I didn't make this super concentrated, no big deal, but that's definitely a pink color. Okay, so a couple more that I wanted to show you. One is, this is called Phenol Red, and so a lot of times you can get these indicators in solid form, and then you just dilute them, and so I just would add, distilled water to it, but this one happens to be already made for me. So this is a Phenol Red. And I'm going to drop the Phenol Red into my acid. And so again, this is my vinegar, and it looks to me like it's yellow, okay? And so this is yellow, and I'll show you in just a little bit on Phenol Red. I'll show you in a chart. So yellow indicates that it's an acid. Okay, and then let's add a little bit of it, same thing, to one of these containers of my base. And so I've got my base, and ooh, that looks pink. Okay, so kind of cool here. We've got some different colors. So that's my Phenol Red. Okay, and so it is like red in color here, but then in the acid it's yellow, and then it looks more pinkish in my base. Okay. And the other one that I'm going to show you is what is called a universal indicator solution. And this pretty much works like the color wheel did. So if you get something more in like the pinkish range, then that should be an acid. And if you get something more in the bluish range, then it should be a base. So let's test out our acid here. So let's drop some of this in our vinegar. And oh, hey, we're getting this like reddish color here. Okay, so if you remember in, for example, with the phenolphthalein actually turned pink in base, which is usually that doesn't happen, okay? But this, usually acids are going to be more in the pinkish range. But when I did test out the phenol red in the acid was yellow. So they do different things. So it's not always a rule to follow. Okay, let's test out and see what happens to my base, my baking soda, when I add the universal indicator to it. And it looks like it's turning more greenish blue, okay? And so that is an indication that I've got a base, okay? All right, so let's take a look at this reading here. So it says the purpose is to acquaint you with different techniques of titration. So it talks a little bit about an indicator and how you have a certain color. And then, for example, you could have, when it breaks up and forms the H plus the indicator, you get a different color. And so depending on which direction it's going, you can get those different colors that happen. And then this is pH. Obviously, we know that if it's 9, and this is saying up to 15, but that would be strongly basic, 1 to -1, strongly acidic. And so here, this is showing a titration curve of a strong acid with a strong base. For a weak acid with a strong base, we can see that the titration curve is starting at a higher pH, which makes sense. So if it is a stronger acid, then it should be a lower pH to start. And so then we get this curve, and then we get this shooting up right here. Notice at 49 mils, your pH is much less, okay? But the question is, where's the equivalence point? Well, since we have a strong base, our equivalence point should be higher, okay? And so we can see that our equivalence point is more like an 8.5 on here, okay? Now, how do you choose an indicator? So you want to make sure that your indicator changes colors somewhere in this region. It doesn't have to change colors right at the equivalence point. So you can see that we have a nice region here where it can change colors, okay? And so when you take a look at some of these indicators, you can see, for example, that bromothymol blue or methyl orange, they change colors kind of in this lower range here, okay? Where phenolphthalein, very popular to use, and people will say, okay, but I'm really confused. Why would you use that if it changes at a pH of like 8 or between 8 and 10? But if you look at if you have a strong acid, strong base, which is, very popular that people would titrate a strong acid with a strong base, you can see that I do have a nice region here between like 4 and 10. So what is a good indicator to use? Well, a good indicator to use is one that is going to change in that range. So as long as I have that range, so that 8 range, 9 range is totally fine, okay, for something like that. And so that's kind of the idea of like how to choose an indicator, is just kind of making sure that it's going to change within that range. All right. And I hope this helped to explain a little bit about how indicators work. Happy day.